Here we have two functions. One of them is a reciprocal function, 1 over x plus 3. The other one is a parabola, x squared minus 4x. We want an explicit equation for each composite function and then figure out its domain. So, to start off with, plug in f of x. Well, f of x is 1 over x plus 3. And then we plug in 1 over x plus 3 into g of x. Well, g of x says whatever you plug in gets squared, and then you minus 4 times whatever you put in. So this is the equation that we have in the end. That's our explicit equation. If you wanted to, you could expand it, or you could just leave it like this. As far as figuring out the domain, when figuring out the domain, what you're really looking for, is there anything we can't put in? Any non-permissible values, any square roots of negatives, those kind of things. Well, in this case, you're not going to be allowed to put in a negative 3, because that would cause you to divide by 0. So our domain is going to be everything except x can't equal negative 3. Now, when checking for non-permissible values, especially dividing by 0, you need to check everywhere in your equation. So right at the beginning, at this point right here, we already knew that negative 3 was a non-permissible value. Sometimes in your equation, a non-permissible value will appear earlier, but later on it disappears, but it's still going to be a non-permissible value. So you have to check everywhere in your equation for those non-permissible values. So in B, f of g of x is x squared minus 4x. Can you see there's no non-permissible values yet? And then f of x says whatever you put in, so x squared minus 4x, you add 3 to that on the bottom. And so now we have our explicit equation. The domain of this one, the bottom can't equal 0. So we need to figure out when is x squared minus 4x plus 3 equal to 0. Well, that's a quadratic. If you factor that, the non-permissible values are 1 and 3. So our domain, x can't equal 1. X can't equal 3, but it can equal everything else. So this is interesting because a non-permissible value of f of x is negative 3. But in this situation, f of g of x, negative 3 is allowed. Because if you plug negative 3 first into g of x, you're going to get 9 plus 12. You're going to get 21. And 21's fine when you plug it into 1 over x plus 3. But now we get some new non-permissible values. 1 and 3 would cause a 0 to happen on the bottom. Okay. 6D. Try that on your own, and then we can look at it together in a bit. So in 6D, we're finding f of x. F of x is 1 over x minus 1. The fact that they give you g of x in this equation, it actually doesn't affect it whatsoever. G of x could be the natural log of that, and it wouldn't matter. Just looks scarier. Okay? Now, what does f of x do? F of x, whatever you plug in, goes 1 over whatever you plug in. So now we're plugging in 1 over x minus 1, and then you subtract 1 from it. So now we have a fraction within a fraction. If we think about how do we deal with fractions within fractions, you try to get a whole fraction on the numerator, a whole fraction in your denominator. So in my denominator, I'm going to have to multiply this 1 by x minus 1 and x minus 1 to get a common denominator, and then I can add things together. So I'm still going to get a 1 on top, and on the bottom, I'm going to have 1 over, I now have a common denominator of x minus 1, and it's going to be 1 minus x minus 1. Can you see on the top you do have a fraction? It's 1 over 1. And now we have a fraction over a fraction, so we can multiply by the reciprocal. Well, that would be 1 over 1 times by x minus 1 on the top, and if I distribute that negative on the bottom, I'm going to get negative x plus 2. So this simplifies completely to x minus 1 over negative x plus 2. So there's our explicit equation. As far as finding our domain, and this is one of the reasons I wanted to do this one with you, is the mistake with non-permissible values that most students make is they only look at your final equation. If I look at my final equation here, my only non-permissible value, x, can't equal 2. But we do have to check everywhere else in our equation to see, have we ever divided by anything else? And the answer is yes. There's lots of places that we're dividing. I can highlight, here I'm dividing by x minus 1. Here I'm dividing by x minus 1. Here I'm dividing by x minus 1. In fact, even here I divided by x minus 1. So if I look at all of those places where I've divided, all the way through, I find out that another non-permissible value is that x can't equal 1. It's not because it's equal to 1 in the numerator up here. That's fine. But the fact that it was equal to 1 previously, that's what makes our domain what it is.